Kia ora. In this video, we're going to be having a look at the simulation model teaching tool on NZGrapher. This tool has two purposes. Firstly, looking at random chance, and secondly, looking at how well a distribution fits some data. So we're going to start off with the second part of that, looking at how well a distribution fits the data. And for that, we're going to use the babies data set. So we're going to come into teaching tools, and we're going to click on simulation model. I'm going to start off by having a look at a continuous numerical variable, and we're going to choose the birth weight because it's nice and easy to understand. This is the weight that the babies were when they were born. And we want to look at different distributions and see how well they fit this data. So we're going to start off with a uniform distribution because that's a nice distribution to use for continuous data. And we're going to do one random simulation. So what this simulation does is it goes through and assuming that we've got a uniform distribution with a minimum of, in this case, 709 and a maximum of 4990, which matches what's in the original data. You can change those parameters if you want to. It will go through and work out a simulation based on the number of data points you had in your original data. So I can do another one, and the previous ones fade into grey on there. So I can do that a few times, and we can see kind of the pattern slowly develop of what we might expect to see. So we like doing 1,000 because that pretty much gets rid of, all of the different possibilities or the vast majority of them. So if I click the fast, it's going to run through the remaining ones to get to 0 simulations remaining, which means we'll have done 1,000 of them. And then it shows it there as a nice grey band. So we can see here that we've got quite a few of our bars there are well below the data and quite a few are well above the data. So I would say for this data, a uniform distribution doesn't fit very well. So let's come and have a look at some of the other distributions that we could look at. We could look at a triangular distribution. So if I come in here, the triangular distribution, it's automatically calculated a possible minimum, maximum, and mode for us. And so let's step through the data nice and quickly there, and we can see that seems to be fitting a lot better than the uniform distribution. It's not perfect though. There's not many times where it's overlapping correctly here in the 4,000 to 4,500 data set. But all of the rest kind of look like they're within the realms of possibilities. Some of these here are a little bit higher. So now that we've tried the uniform and the triangular, let's try the normal. Again, it's pulling the mean and the standard deviation from the original data set, and it's performing a random simulation with 189 data points and plotting what that would look like over the top. So, that's looking pretty good. So let's get that going nice and quickly and see what that looks like once we've run that through 1,000 times. So looking at those three different graphs, I would say that the normal distribution is by far the one that fits that data the best. Now, what happens if you don't have a continuous variable? Let's say you've got a whole number variable. So let's come and have a look at FTV. FTV is the number of visits the physician makes during the first trimester to the mother. And we can do a couple of different distributions for that. We could look at the Poisson distribution. So again, I will step through that quite quickly. Same principle, it overlays what the data looks like over the top. So that's a Poisson distribution. We can do the same with a binomial distribution. Or we could do the same with equally likely. Now the way equally likely works is it assumes that each of the numbers along the bottom here are equally likely to happen. So that ends up looking like that. So that one there very much does not fit the data well at all. The other way you can use this is you can look at comparing data from an experiment to what might have happened if you had simulated the data. I've got some data here from rolling 3 dice. So what I'm going to do is we're going to come back into that simulation model teaching tool, and we're going to look at the dice 1 rolls. So this here, I rolled a dice 30 times and I got 10 ones, I only got 1 2, I got a few 3s, some 4s, some 5s, and 3 6s. So is my dice unfair, or is this likely to have just happened by random chance? So let's go through and do some random experimenting and see what happens. So I'm stepping through slowly. So far, none of them, there's been a few there where you only get one at a time. And now we're getting some on the 2 as well. So let's go through and we'll step through that quite quickly. So what we're getting here is the grey band is showing the possible outcomes from running the simulations. So looking at this, while that data looked quite unusual, it is actually well within the bounds of what you might expect from rolling a dice 30 times. And that's the simulation model teaching tool on NZGrapher.